So let's think back to Unit 2, Chapter 1 in our textbook, and what happens in a typical car combustion reaction. So remember, we have our inputs. We have gasoline and oxygen yield CO2 and water, and this is when everything is going well. But there were also some pollutants that we talked about. And one of the things that we discussed is that combustion engines generate a lot of heat. So our normal atmospheric gases of nitrogen and oxygen are typically not very reactive. But when there's a lot of heat, then our nitrogen and oxygen can combine to form nitrogen monoxide. This nitrogen monoxide can combine with oxygen to form nitrogen dioxide. And sometimes we'll lump these pollutants and call them NOx as nitrogen monoxide or nitrogen dioxide. We also have other pollutants that we got from our cars, like carbon monoxide, VOCs, and ozone. In contrast, let's think about what happened with our coal-fired power plant. So in this case, we have coal, which we can approximate as largely a carbon and hydrogen compound, but we also have some oxygen, some nitrogen, and some sulfur. The sulfur we're going to see is important. When we have a coal combustion reaction, again, we have our coal plus our oxygen yielding CO2 and water, but this sulfur can also combine with oxygen to form sulfur dioxide. Sulfur dioxide, once it's in the atmosphere, can combine further with oxygen to form sulfur trioxide. So we know that we have some pollutants from cars and from coal-fired power plants, but we still don't know how this leads to acid rain. Let's work on completing the story of acid rain. When we analyze rainwater that has been collected, and we find that acid rain contains compounds of sulfur and nitrogen, namely sulfur dioxide, sulfur trioxide, nitrogen monoxide, and nitrogen dioxide, the very compounds that we talked about on the previous slide as originating from coal or from cars. But how can SOx and NOx be acidic? They don't have a hydrogen group. These oxides of sulfur and nitrogen are called acid anhydrides, which literally means acids without water. SOx, when it reacts with water, forms an acid. In this reaction, the SOx dissolves in water and forms sulfurous acid, which is a weak acid. Sulfur trioxide dissolves in water and forms sulfuric acid, a strong acid. So the sulfurous acid will dissociate slightly. The sulfuric acid will dissociate completely. The NOx undergoes a similar reaction in that it combines with water to form nitric acid, another of the strong acids.